You know, for basically all of human history, from the first time we took a step to the most advanced rocket launch, one single rule has always applied. To move forward, you have to push something backward. But what if that rule could be broken? What if you could generate motion not by shooting stuff out the back, but by tapping into the energy that's already locked inside an object? Today, we are diving into a really revolutionary idea that might just do that, using something called nuclear magnetic resonance to turn internal energy into actual physical momentum.
I mean, just look at any modern rocket. It's beautiful, but that massive structure is mostly just a giant fuel tank. We're talking up to 90% of its weight is just propellant that it has to carry, all so it can throw it out the back. This is Newton's third law in action, and honestly, it's the fundamental bottleneck of space travel. It traps us in the brutal math of the rocket equation, where every extra bit of distance you want to go requires exponentially more fuel, which of course then requires even more fuel just to lift all that fuel off the ground.
But you have to ask yourself, what if that entire way of thinking, the one that got us to the moon, sure, but also limits us, what if it's all based on an incomplete picture? What if the universe has other, kind of more elegant ways to get from point A to point B?
And that question brings us to a truly disruptive idea, the hypothesis that you can generate thrust without pushing on anything at all.
This is the core idea right here, generating movement using only the energy that's already contained inside an object. Just imagine that for a second. No propellant, no exhaust, no mass being violently thrown out the back. The solution isn't a bigger engine. It's something hidden deep, deep within the fabric of matter itself.
So, okay, how is this even possible? I know, it sounds like you're getting something for nothing, which is a huge red flag, a classic violation of the laws of physics. But the secret here isn't about breaking the laws, it's about using a deeper, more fundamental one.
And that law is the conservation of angular momentum. To put it simply, the universe is like a meticulous bookkeeper. If a system, let's say our spacecraft, starts out with zero spin, then the total amount of spin in that system must always add up to zero. Any change in one direction has to be perfectly balanced by a change in the opposite direction. No exceptions.
You've seen this a million times with an ice skater. When she's spinning and pulls her arms in, she suddenly spins way faster. She hasn't pushed off anything new, she's just rearranged her own mass. Her rotational speed changed, yeah, but her total angular momentum stayed perfectly constant. The universe's books stayed balanced.
So, the big question is, can we create this ice skater effect? Not with arms and legs, with the very building blocks of matter itself. Well, to do that, we have to go down to the atomic level.
The key to this whole thing is a technology called nuclear magnetic resonance, or NMR for short. See, deep inside every atom, the nuclei of certain elements are basically behaving like these microscopic, perpetually spinning tops. Every single one of these tiny tops has its own angular momentum. And NMR, well, it gives us the tools to control them.
So here's how it works, in 3 key steps. First up, alignment. You take your material and you stick it in a strong magnetic field. This gets all those tiny atomic tops mostly pointing in the same direction. Second, you have the trigger. You hit them with a precisely tuned radio frequency pulse. Think of it as a perfectly timed electromagnetic kick. This forces all of those nuclei to change their spin at the exact same instant. And third, and this is the magic moment, the reaction. By forcing trillions upon trillions of atomic nuclei to suddenly change their spin, the law of conservation demands a response. To keep the books balanced, the entire object has to rotate in the opposite direction.
Okay, it is a beautiful theory. It's elegant. But does it actually work in the real world? And that brings us to the landmark experiment that was designed to prove it.
The material they chose was bismuth. And you might ask, why bismuth? Well, because its unique crystal structure, it's called a rhombohedral lattice, it basically acts like an amplifier. It arranges all of its little atomic nuclei in just the right way to make them super responsive to magnetic fields. It was the perfect candidate to see if you could translate this tiny microscopic resonance into real macroscopic movement.
So here we have it. On the left, that's the setup, a simple bismuth disk sitting inside a powerful magnetic field. And on the right, that's the data. This sharp vertical line, that marks the exact moment the radio frequency pulse was fired. And this curve you see, that's the actual physical movement of the disk itself. So the big question is, did it work?
Oh yeah, it moved.
The data was crystal clear. A partial rotation of the disk was observed. And,
As the research confirms, that movement happened only at the precise moment the RF pulse hit it. There was no external push, no propellant, just a clean conversion of atomic energy into motion. The theory was confirmed.
The success of this experiment, it doesn't just validate some clever theory. It feels like it opens the door to an entirely new frontier in physics and in engineering. What we're looking at here is a direct conversion of electromagnetic energy into mechanical work. And the implications, they're just staggering. We're talking about spacecraft that don't need to be 90% fuel tank, satellites that can maneuver for decades, not just a few years. This could completely change the game, massively reducing the weight, the cost, and the complexity of literally everything we send into space.
This discovery really forces us to ask a profound question. It doesn't break the old laws of physics, not at all, but it uses a deeper, more fundamental law to achieve something that we all thought was impossible. So, the question is, have we just found a clever loophole in the rules of motion? Or have we just been handed the key to an entirely new chapter of physics?